we learned. The first class we looked at about the course content. So this, as I mentioned, collections and DSA, and it's a collections we talk about briefly. All this, whatever you are seeing on my screen, and in data structures, time, space, complexity, all sorting techniques, graph, dynamic programming, matrix, pattern printing, and various questions. And these are the hacker rank and lead code or hacker earth. These questions we are going to solve. And we started with yesterday with a what is the time complexity? Can someone summarize what is the time complexity, what is the space complexity, and how we denote?
Time complexity is like the time which required to execute execution for a program and for the task. Or space complexity is space taken by the application to run.
Yeah, how do we denote? Can I say that time complexity is nothing but time taken by the program? It's my like 2 hours, 3 hours, or 10 seconds, 20 seconds, like that. And what is the problem with that?
It may vary system to system for the time complexity, but and we
Yeah.
can.
So whatever you are running in a system which has 8 GB, if you run with the program again on the same laptop, the results may vary. If it is some different combination, definitely the time taken by the program will reduce, right? So it depends on hardware. So that's the reason we don't denote the time taken by the program in terms of minutes or hours. We denote by using a notation called big O.
We go.
Which we have seen yesterday, right? Big O notation, right?
Yes.
So, and we also have seen that the space occupied by a program is space complexity, and that also we do not denote using like 4 MB, 5 MB, or 10 MB, something like that. The reason for that would be even the variables that are created by Java will occupy a different memory, right? Each will occupy a different memory based on your operating system configuration or the bit computer that you have. Yesterday I've shown in the Google. So now that also will be depends on the system configuration. Hence, the space complexity also will be denoted in terms of big O notation, right? And if I have, this is a for loop, simple for loop, what would be the time complexity and what would be the space complexity for this program?
It's O of n.
Yeah, big O of n, correct? So if I take out this integer variable, then what would be the space complexity?
It's O of n only once.
It's a big O of 1 only, not n. Because the integer variable will be there is inside a for loop, you are doing a computation. But are you creating any new memory?
No.
No. So if you earlier what is happening? How many times your loop runs? The same number of times the variable will occupy the memory, correct? Integer x. But here if I comment this, so what you are doing? You are not creating any new memory, right? So during the space complexity, you will check for how much space is taken by the program, not the how many times it's occupying. I mean, how much space is taken by the program, not how many times the loop is executing, etc. Right? So even though if you execute this for 10,000 times, only existing variables will be used, and it will the value will be reassigned to those variables. Correct? It is a shallow copy, not the deep copy. So hence, now if I do not have any variable inside a loop or something, the time space complexity would be big O of 1. Big O of 1 is called as constant space complexity. I repeat, big O of 1 is called as constant space complexity. That means how many number of lines code, the lines of the code you have, your complexity would be 1 only. So next we will be looking at bubble sort, and we'll go with an example. So and big O of n is called as linear linear complexity. If it is a time, you are talking about a time, then it's a linear time complexity. Does anyone know why it is called as linear? So now here, for example, what is a big O of 1? For example, you have x-axis and y-axis. So the number of times your loop will execute depends on your n value. If n increases, your loops also will be increasing, correct? See, for example, n equal to 1, this is 1. N equal to 2, this is 2. N equal to 3, this is 3. N equal to 4, this is 4. Now, if I club this, all this, then it will go like this, right? This is a linear line, right? That means as whatever the change in x variable, the same change will be reflected in the y variable. So it can be that means it can be y equal to 2x plus 3 or anything. Like this 3 is nothing but your intercept of y, correct? When x equal to 0, where do you start 3? That means 3 like this. So, but here if you do not have this one, it passes through 0 onwards, correct? So a big O of n is called as linear complexity. It can be space or it can be time. Any questions so far what I have explained? Yeah, looks like no questions. So let's continue for further. So now today we are going to talk on topic of bubble sort. Now let's take some numbers. So let's take descending order. See whenever there is a sorting technique, what is the objective, guys? What with the sorting technique, what do we do?
We sort the things by arranging or descending order.
Arranging order, correct? Like general followed order is sorting, arranging, ascending order, correct? Now
Mhm.
let's take yeah. So let's take these are the numbers. So these numbers are in descending order, correct? N- Now let's take one more number here. Uh, let's take some number 13. So now this is not descending order; it's some random order. Now, how does the bubble sort will work? So whatever may be the sorting technique, you will be given with an array or array list or some list of numbers or some array of numbers, and you have been asked to do sort the numbers. At the end of the any sorting technique, the output is sorted order, either it is the ascending order or descending order. Generally, we follow ascending order. Now the question is, each algorithm has its own way of doing the things, and depending on the use case, you will be using what type of algorithm I should use. I'll be explaining that too, but let's see what is algorithm for bubble sort. So what does a bubble sort will tell you is compare the each element with the adjacent element. Let me write here, compare each element with its adjacent element. If the element in lower index is bigger than element at higher index, swap and continue till end of the array. So continue this logic till end of the array. So what does it mean? So compare the each element with its adjacent elements. Now let's do what are the first two elements? 13, 91, 81, 47, 37, 21. Let me take different color. Now you compare the each element with adjacent element. So if the next step is if the element in lower index is bigger than the element at higher index, what is the meaning of this one is? See here, whenever you take this an array, so what are the indexes, guys? 0, 1, 2, 3, 4,
0, 1,
5.
2, 3, 4, 5.
Yeah. Now, lower index is nothing but this one. Correct. If you first you start with the 0th index, that is a starting point we know, right? So you compare with 0th index and first index. Now, what is 13? Is bigger than 91. Is it true or lesser than 91? 13 is
Yes,
lesser
sir.
than 91. This condition is true. If this condition is true, what does it mean? The elements are in order or not in order?
Order.
Order.
Order. So do you need to do anything?
No.
No.
No. So that is what I am saying. If the elements in the, yeah, there is some background noise. Yeah. Just whenever you want to speak, unmute yourself and then go back to the mute. Thank you. So what it is telling you that if the element in lower index is bigger than the element in higher index. This condition, see, element in lower index is 13. Is it bigger than 91? No. So that's the reason you don't do any swap. Now let's, if for example, now what is the meaning here? 13 less than 91. This is in a proper order. You don't need to do anything. Now let's go. Let's go to the next. Next, what do you compare? You compare the next indexes. What are the next indexes? 91. See, first index and second index. Now, 91 less than 81. Is it in proper order?
No.
No. What does it mean? Element at lower index, that is nothing but element at first index is bigger than element at second index. According to the algorithm, what I have to do? Swap, correct? Now that means this will go here, this will come here, correct? Now 13 comma 81 comma 91 comma 47 comma 37 comma 21. This is a new array, agree?
Yes, yes.
Yeah. Now again, same. I think I should continue till the end of the array, same logic. Now this is completed. This we are completed. Now what are you going to do? You need to compare these two. 91 less than 47. What does it mean? Element at lower index is higher than the element at higher index. So that means these are not in a proper order. I should do swap. So it will come here and this will come here. 13 comma 81 comma 91 comma sorry 47 comma
91.
91 comma 37 comma 21. Next same thing for this, correct? Next element 91 less than 37. Yes. So it will come here. This will come here. 13 comma 81 comma 47 comma 37 comma 91 comma 21. Next, these two elements 91, 21. So which is not in proper order, it will go here and this will come here. 13 comma 81 comma 47 comma 37 comma 21 comma 91. Now, do I have any other elements to compare? Do I have any other elements to compare or did I reach to the end of the array?
Yes,
We
yes.
have
We have to
81.
repeat the same.
No, no. In this element, I see. I started this 91 comparing with 81 already, right?
Yes.
No, no. I'm saying whenever I started comparison, I started with 0th index. And I've taken till I have reached till the end of the array. Now, in this all elements, this is your, see, this is the result. Something, some result you got now. Now, what is the observation from this result? And can anyone tell me?
Still, we are not with the sorting order, and but we reach to end of the element.
Yeah. So based by if you look at this one, what is your observation? What do you think?
Ascending order.
No, it is not ascending order.
The highest value went to last, sir.
Yeah. So that means, can I say that 91 is sorted?
Yeah.
So now if you look at here, whenever you say an element is sorted, what does it mean? It should be in a right position, correct? Before that element, maybe or may not be sorted. After that element, maybe or may not be sorted. If you look at here, 91 is, whenever you start a problem, is the 91 is in a right position?
Okay, fine.
In the array, this is a given array. In this given array, is the 91 element is in a right position?
No.
No. Now, but after doing your logic, all this, is your 91 is in a right position in the entire
Yes.
given array?
Correct.
That
Yes.
means, so now, and if you look at, as Nagaraju said, right answer. So if you look at 91, what is the, in the entire array, what is the biggest value? 91. 91 has come to the last position, correct?
Correct.
So this is iteration 1. This is iteration 1. So in the bubble sort, what will happen? Each iteration or iteration, the algorithm looks at each element and it compares with the adjacent element. And if there is a need, it will do the swap. And at the end, the last index will hold the highest value of the array. That means this 91 is sorted. Now, what is my work? If you look at the remaining elements, are these sorted?
Oh, no.
No. So I should apply the same algorithm for the remaining elements, right?
Yes, yes.
Yeah. So let's do that. Apply the same algorithm for the remaining elements. Now, what are the remaining elements? Same logic again. 13 less than 81. Is it, do I need to swap?
No.
Not required. Next, these two. 81 less than 47. Do I need to swap?
Yes, yes.
So I'm changing in this one only. 47, 81. I think, yeah, Raju, there is some background noise from you. Just check. Okay. Now next, this is done. I just moved it. Now next, what are 81 and 37, correct? Do I need to swap? 81 and 37. 81 less than 37, I should swap,
Yes.
correct? So 37 will come here. 81 will come here. Next, 81 less than 21. What should I swap? Yes. 21 will come here and, sorry, 27 or 21. 21 will come here and 81 will come here. Now, what is your observation?
Second highest.
So this iteration 1 is completed. Now iteration 2, the second highest value has come from last but one position, correct? That means, can I say that bubble sort is doing the sorting from last to first, correct?
Yes.
Yeah. So now that means, can I say now each iteration, if the first iteration, then last element will be sorted. Second iteration, last but one. Now I need to do the remaining algorithm for these 4 elements, correct? Now 13 less than 47. See, why should I do like this? Because this is the algorithm you need to follow. Like whenever, see, if you look at Java, first initially they implemented, they do not have the collection framework. In 1.2 or 1.2 only the collection framework has been introduced. Why? Because when they look at initial Java, they identified that there is a problem, so they come up with that. Now, similarly, bubble sort is one technique. It has its own algorithm. Now, later point of time, they found some other algorithm which is better than this one. So that is a merge sort. Now, but when should I use bubble sort? There is a different use case. I'll explain. Now, in the iteration 3 now, in the third iteration, 13 less than 47, no change. Next, 47 and 37, change, correct? 37 will come here, 47 will come here. Now, next to 47 and 21, yes, 21 and 47. Now, if you look at in the third iteration, can I say these 3 values are sorted now? Last but 3 is sorted. Now, next, you do the sorting for this. 13 less than 37, yes. 37 will come here. Sorry, it is correct, right? It is right in order, right? I don't need to do anything, my mistake. Now 37 and 21, yes, 21 will come here and 37 will come here. Now if you look at here, this is sorted and these are also sorted. That means entire array is sorted, correct? Now this is how the bubble sort works. Do you guys need one more example? Shall I explain with one more array?
No, sir. It is understandable.
Yeah. What about others?
Sorry, is that fine? But that big notation of an unlinear, that
I'll
how
come
to...
to that. I'll come to that. We did not see, look at the code and all that. I just explained the algorithm. We'll convert into a code and then we'll try to find out what is the time complexity, everything. It takes time, little. Just wait for some time. But does everyone understood, or do you guys need one more example?
Understood.
Yeah,
No
thank
need,
you.
no need actually.
Yeah. So now let's look at how can I convert this into a code. Now, basically what it is doing, at each iteration, it is comparing the first element with adjacent element. And then if it is bigger, you are swapping and then continuing with all, right? Now let's write. Now, what I'm doing here, first what I did, 13, I checked 13 less than 91, correct? If it is true, did I do anything? If this
Nothing.
condition is true, I did not do anything. That means when if it is not true, then I have done the
We
swap.
need to swap.
Yeah, swap, correct. Now, can I write in a opposite manner so that I can do the swap, correct? Right? I can write like this, correct? Right? Now, what is the where the 13 is present in the array? What is the position for 13?
0th position.
0th position. Can I put a of 0?
Yes, we can.
Yeah, now 91 is nothing but a of 1. Now, if a of 0 is greater than a of 1, now the condition is
False.
13 greater than 91. So, first time it is false. You don't need to do anything. Next, let us take that this number is not there for you. For time being, you take that this number is not there. And the array starts with 91 and 81. 91, comma 81, comma 47. I'll come to this one. Assume that this is your array. 91. So a of 0 will be 91 and a of 1 will be 81. 91 greater than 81. Is it true?
It's true only.
Yeah, if it is true, then what am I supposed to do? I need to do the swapping. How do you do swapping in Java? You take some temporary variable, temp equal to a of 0, a of 0 equal to a of 1, a of 1 equal to temp. Correct? This is a general way of writing a swapping logic. Yeah, Raju, still there is some background noise. Can you please check that? It might be disturbing for the others. Okay. Yeah, so this
Yeah,
is how
I'm
I do
sorry.
the, yeah, we do the swapping for this. Now, let's go back to the original array. Now, 13, so a of 0 is 13, 13 greater than 91. Is it true? No. But this is normal value, normal code to check the values. Now, what should I do? If it is not done, according to the algorithm, what I have done? 13 greater than 91, there is no change is needed. Then what I did? I compared with next elements, correct? 91 greater than 81. I went to the next elements. Now, how did I go to the next element? If I hard code the value 0 and 1, can I go to the next element? In Java, what should I use to continue this logic till the end of the array? So, can I say that I should use one loop to iterate it, correct?
Yes.
Yeah. So, let's use for I equal to 0, I less than n minus 1, I plus plus. So, do you guys understand why should I go for a loop? Because you need to do this logic, this comparison logic till the end of the array, right? So now instead of I, can I put some variables, correct? A of I is greater than A of I plus 1, correct? Now if you look at when I equal to 0, you're comparing A of 0 with A of 0 with is greater than A of 0 plus 1, which is nothing but 1. Now, is it true? 13 greater than 19, is it true? No, if it is true, you will go inside it. If it is not true, then what will happen? Then I plus plus, I value will become 1, right? Now, what will happen? A of 1, you are comparing with A of 2. That is my intention, right? Now, once this is done, according to your algorithm, 13 greater than 19, it is not true. Now, next, what are you doing? 91 greater than 81, is it true? So that means you are comparing first index with second index. Now, the same thing happened. Look at here. A of 1 is greater than A of 2, which is nothing but 91 greater than 81. Is it true? Yes. Then what are you doing? You're swapping. Temp equal to, instead of 0, can I put A of I? A of I equal to A of I plus 1. And A of I plus 1 equal to temp. Now, this is a temporary logic, swapping logic. So that what happens? Let me write the numbers here. 13, 91, 81, 47, 37, 21. Now currently I equal to 1. Okay. Now can I say after this loop is completed, I equal to 1 is completed, 81 will come here and 91 will come here. Yeah, those who do not have a problem with your audio, you can speak with me. I mean, instead of one person talking, let's make it as interactive. Okay. So now after this loop is completed, can I say that this is my output?
Yes, Karthik.
Yeah. So now
Yes.
next, what will happen? I plus plus. Now till I value till will n minus 1. What is a length? N is nothing but a length. 1, 2, 3, 4, 5, 6. 6. Now I value is 2. 2 less than 6. Is it true? Yes, correct. Now A of I, that is nothing but A of 2, is greater than A of 2 plus 1, is greater than A of 3. What is the value of A of 2? This is a new, correct, array. 91. 91 is compared with 47. Is it true? Yes. Again, you do the swap, correct? Then that means 47 will come here. 91 will come here. Next, I plus plus. I value will become 3. 3 less than 6. Is it true? Yes. A of I is greater than A of I plus 1. A of I is nothing but 3. A of I plus 1 is nothing but 4. Now, that means this, what will happen? This 91 and 37. 0, 1, 2, 3. Correct? 3 is nothing but 91. 91 and 37 is compared. Yeah, it's bigger. So 37 will come here. 91 will come here. Next, I plus plus. I value will become 4. A of 4, 4 less than 6. Is it true? Yes. A of 4 is less than A of 4 plus 1, 5. Then what will happen? 91 greater than 27. Yes. So 21 will come here and 97 will come here. Now, now what happens? I plus plus. Whenever you do I plus plus, I value will become 5. Now, A of 5 is greater than A of 5 plus 1, A of 6. Now, in this array, what are the indexes, guys? This is a given array to you. What are the indexes? 0, 1, 2, 3, 4, 5. But here, if you look at here, you are getting a 6th index. That means what error you will get?
Array out of.
So then what should I do? I should not go, correct? See, when I have compared this one already, correct? Because I'm putting I plus 1. So can I say n minus, what should I write the condition? That means I should skip this condition, correct? You agree what I'm trying to say?
Yes.
So, I mean, this is a one I have written wrongly. For example, if you, okay, let us take that if you are writing I less than n. So what is the n value? N is nothing but number of elements. Number of elements is 6, correct? So I should do my condition till 5 only, correct? Because I am doing 5 plus 1. If it becomes 6, right? So if I say n minus 1, n minus 1. So what is my condition? My condition becomes 5. So 5 less than 5. So whenever your I value is 5, 5 less than 5, the condition itself false, it will not come inside the loop, correct?
Yes, sir. You made n minus 1. Yeah.
Yeah. So if you, do you guys understand why generally whenever you write a loop, you write for I equal to 0, I less than n, I plus plus. This is the general way of writing a loop. But now what I'm trying to say you guys is, instead of n, I have written n minus 1. Do you guys understand why did I put n minus 1? If I put n value is what? 6. Whenever the I value is 5, 5 less than 6, the condition is true. And at this if condition, the condition looks like A of 5 is greater than A of 6. But do you have a of 6 index in the array? No, you will get out of array index out of bound exception, right? To overcome that one, so I am checking till n minus 1, which is nothing but 5 minus 6 minus 1, 5. 5 less than 5, the condition is break. The loop is broken. Once the loop is broken, whenever the loop is broken, what does it mean? You completed one iteration. And how does the array looks like? This is your array after the loop is completed, correct?
Yes.
Yeah. Now what you need to do?
Iteration 2.
Yeah, in the iteration 2, what are you doing? Same you are doing 13 less than 81, correct? That means in the iteration 2 also, are you doing the same logic? Whatever I have executed this for loop, are you executing it again?
Yes.
So in order to do that, what should I do? This entire code, I should put it in one more loop so that it will be executed, correct? So that is the reason we write outer for loop for I. So here, if you take I, then let's take j equal to 0, j less than n or n minus 1, j plus plus. Now, see, this is the external for loop, external for loop. Okay. Now, what is the use of internal for loop? What does the internal for loop will do? Internal for loop will do this step, correct? Compare each element with adjacent element. If the element is in lower index is bigger than the element in higher index, then it will swap. So that means this inner for loop will start with a 0th index and go to the last index, and it compare each element. And if the element at lower index is bigger than the element at higher index, it does the swapping. That's it. But once you complete the inner for loop, uh, then this is your result. But what you need to do? You need to apply this kind of a logic for rest of the elements. That is the reason I have kept I outer for loop. So when I equal to 0, that is called first iteration. So the outer for loop is nothing but I have kept j. So when j equal to 0 is the first iteration. In the first iteration, what you have done? You started with 0th index and you compared with all the elements, and this is output you got. Done. Now next, j equal to j plus plus means j equal to 1. Whenever j equal to 1, again what do? You compare same thing. 13 is greater than 81? No. 81 is greater than 47? Yes. So you swap, correct? 47, 81. Now 81 next, I plus plus. 81 is greater than 31? Yes. So 31 will come, 81 will come here. Now 81 is greater than 21? Yes. 21 will come here and 81 will come here. Now once you reach, once you break the loop, inner for loop, then you completed the inner for loop for j equal to 1. So last but one element is sorted. So the outer for loop is for iterations and the inner for loop is for algorithm steps, like compare each element with adjacent element, and if it is bigger, then swap it. This is why we should write. So can I do this with sorting technique with single for loop?
No, sir.
No, you cannot, right? Because the algorithm says different steps. In order to follow that, we need to hold the two for loops. Any questions? This is just pseudo code. We'll write a code, but does anyone has any questions so far, whatever I have explained? Yeah, I take that silence as
Sir,
no questions. Yeah.
Can you
can you
Go.
take that this one, sir? You started J, right?
Hmm.
So J is 0. You started from this one, and I we can take J plus 1, and
Yeah, you can write that. We can write.
yeah. No.
No, you should not write I equal to j plus 1. Whenever you, because if you, for example, when j equal to 3, if you write I equal to j plus 1, what is your starting point? 3 plus 1, 4. That means you are starting with this index or this index. But what does the algorithm is telling? Always you need to start with 0th index, right?
Okay.
Okay. So j plus 1 will take in some other algorithms, maybe insertion sort. Okay. Yeah, there was some other question from someone.
can you please explain that external and internal loop again?
Okay. So now, okay. First of all, are you comfortable with this steps?
Yes.
Yeah. In this steps, the way what we are doing, in order to compare each element with adjacent element, and till the end of the array, I have to see this is your comparison, right? So let me draw this one green color. So this is a core logic of comparison. This if block is comparing element with the adjacent element, and if it is bigger, it's swapping. But why should I need a inner for loop? I have to extend this logic to the and all the elements of the array, correct? So that is the reason we have used this for loop, correct? What this for loop is doing, it is starting with I equal to 0 and going till the end of the array and checking 0th element with the first index. If 0 is bigger, it will swap. Next, 1 and 2, next 2 and 3, next 3 and 4, 4 and 5, 5 and 6. So that means this inner for loop will compare each element with its adjacent element. And if the element at lower index is bigger, then it will do the swapping. Is it clear, this logic?
Yes.
Now, whenever let us take that I do not have an external for loop. When I run this program, the initial output will be like this, correct? 13, 81, 47, 37, 21, 91, correct? This is the output after running this for loop. This is the output. You agree with me?
Yes.
Now, if in this output, the last element is sorted, correct? But what is the meaning of sorting technique? You need to do the sorting of all the elements, correct? Now, in this array, which element is sorted? 91 is sorted, but remaining elements are sorted. 13, 81, 47, 37, 21. Are these
No.
sorted? No. So
No.
that means in order to, now I need to sort the remaining elements. Now, what should I do? I should apply the same logic, right? Whenever I am explaining the algorithm steps, what did I do? Next, this is the iteration 1, correct? So this is the iteration 1. In the iteration 1, I got the last element. Then next step, what did I do? So I have taken the iteration 2. In the iteration 2 also, what did I do? 13 greater than 81. Is it true? No, you don't need to do anything. 81 greater than 47. You need to swap, correct? So let's write array here. 13, 47, 81, 37, 21, 91. 91, keep it last. Now I did the swap here. Now next, I need to continue. Compare 81 is greater than 37. Yes. So you swap. 37 will come here. 81 will come here. Right? Next, 81 is greater than 21. Yes, it is true. So 21 should come here. 81 should come here. Correct? This logic has to be executed again. Now in this, whenever you do like this, then what happened? The last but one element, see 81 is also sorted, correct? You are with me?
Yes, understood.
Yeah. Now, what does it mean? See, first, after doing this inner for loop, I got this logic. Now, in order to make the remaining elements sorted, what should I do? I should execute the similar logic, correct? Whatever I have written inside this for loop, I should execute multiple times. So that is what is the way to execute a logic multiple times, right? Another loop. You can write while loop or for loop, anything is fine. Okay, now that is the reason we have written external for loop. The external for loop will tell you iterations. The internal for loop will do the logic. Hope
Okay,
you
understood.
understand it. Any further questions, anyone? Or shall we write into a code and see? Okay, silence means I take no questions. Let's try it. So this is how I explain for each and every algorithm. It's like even if it is a quick sort, merge sort, or whatever may be the sorting technique, I'll explain the concept and we'll write a pseudo code and then we'll convert into a code. In that way, you don't need to remember the code. You just need to remember the concept. So I just created a class called bubble sort. So let's create int array equal to, so 13, 91, 81, 47, 37, 21. This is your given array. Now I need to write a logic, right? So I'm just writing static public void bubble sort. This is a method. So this method takes this array as an input. into array. Okay. Now, what is the first thing I have done? So each element should be compared with adjacent element, correct? So how do I get each element? A of 0, I'm comparing with A of 1. If this is true, what does it mean? I'm swapping int temp equal to A of 0, A of 0 equal to A of 1, A of 1 equal to temp. This is my logic, correct? But here, if I write like this hard-coded values, can I extend this logic?
No.
No. So then in order to extend this logic, what should I do? I should write a loop, correct? Now let's write that. For I equal to 0, I less than a dot length. Let's put I less than a dot length, I plus plus. Okay. Now here, whenever I equal to 0, how do I get 1? So can I put I plus 1, correct? I plus 1. Now let's change it to I plus 1, I plus 1. Okay. But now what is the problem in this one? So here in this code, let's see where if there is a problem. Now, what is the length of this array? 1, 2, 3, 4, 5, 6. So that means a dot length is 6. So 0, I equal to 0. Initially you called I equal to 0 and 0 less than 6. Now let's take, I mean, the value will be continuously incremented, right? Let's take you started with 0 and you are at I equal to 5. Let's take 5. Okay. When I equal to 5, what is the condition 5 less than 6? Is it true? Yes. Then what will happen here? The condition looks like A of 5 is greater than A of 5 plus 1, 6. But whenever you have an array, this array, can you find A of 6? In this array, can you find A of 6?
No.
No. That means what will happen? Array index out of bound exception, correct? So that means since you are using I plus 1, you don't need to do till length, correct? So I need to end my logic before this one. So that is the reason I am putting I less than a dot length minus 1. If I put length minus 1, my length is 6. 6 minus 1, 5. Now 5 less than 5. What is the condition true? 5 less than 5? 5 less than 5. Is the condition true?
No.
No.
False.
So that means the loop will not it will not enter this loop and the exception will not come, correct? Now now let's run this program and call this method from main method. Bubble sort and I am passing. Now let's print. Let's use only one for loop and see what will happen. System.out.println arrays.toString. So since it is an array, in order to print it, I should use arrays.toString method, right? So what I'm doing, I'm just writing only one loop and I'm calling this method and then printing. See, what is the output I got? Is it sorted first of all? Is the array sorted?
No, sir. Only
No.
the last element.
Only one element is sorted, that is nothing but 91. But what is my objective in the bubble sort or any sorting technique? Entire array should be sorted. That means using a single for loop, are you able to do?
No.
No. So that means this now, using this logic, what did I do? I made one element is sorted out of this array. I made one element is sorted, correct? Now I can use the same logic to sort the entire array. So that is the reason I can use external for loop. For j equal to 0, j less than a dot length, j plus plus. Either let's put j less than and see. Now I just added external for loop and then I'm trying to print. Now, do you see what is the output? Is it sorted?
Yes.
Yes, correct. So why do we need the external for loop? Because the internal for loop is comparing each element with its adjacent element and making the element to be in a right position. That is for one element. But in the array, you can have multiple elements. The outer for loop is making sure that you have multiple elements. Now, can I write this code with a while loop or should I use only for loop? What type of loop you are using doesn't matter, correct? Can I write it with a while loop? Yes, let's change this one. So if I use while loop, what should I do for while? I should do initialization outside, correct? J less than a dot length. Now, where should I write increment the value inside the loop? J plus plus, correct? What, see now, inner loop also I can convert, correct? What I can do, I int I equal to 0. For I can change it to while I less than a dot length. I can take out this and I can put inside this while loop, correct? Yeah. So can I say now what loop you are using doesn't matter. You can modify the code accordingly. Now let's run the program and see. See, I still got the output, right? Okay. Any questions? So this is how the bubble sort works. Now the question is, sir, if I'll give you, so in the next class, in the tomorrow class, so here what now? There is generally I use manual debug. What does a manual debug means? In order to understand this program, have you guys debugged in the Eclipse? Did we do the debug in the Eclipse to understand this flow of execution?
Yes.
I mean, when I say debug in the Eclipse, so generally you put a breakpoint and right click, debug as Java application, you do like this, right? Did I do this? To understand each value, did we debug the program like this? No, right?
No.
So now what you have done? So I have written, we are ourselves did the debug like a compiler, whatever the Eclipse is doing. So we did that, right? That is called manual debug. So if you try to do the manual debug, it will improve your abilities to understand the code. Okay, that is the one we do generally in every program. You don't need to debug manually unless until if there is an issue. Okay, now the next question would be, sir, I'll give you the now. What do you see in the A1 line number 10? How does the array looks like?
Ascending order.
So the array itself is ascending, correct? Now if you call the algorithm, still it will do the logic, correct? That means still it takes
Yes, yes.
time. So if your input is sorted already, do you need to do this, all this? No, correct? So how to handle this one? See, generally everyone will write this code by butifying or concept wise. But now the question comes, I am giving you the input which is already sorted. Do you still need to execute all these iterations?
No need.
Not required. Now, how to do that? We will see in the upcoming class. And then another thing also now for this program, what would be the time complexity, right? If it is a array is sorted, what is the time complexity? If array is not sorted, what is the time complexity? Which we will be seeing in the tomorrow class. When I say tomorrow, Saturday, Sunday, there is no class. The next class is on Monday. And tomorrow and after tomorrow, like Saturday and Sunday, no class. Next class is on Monday, which is 25th. And once we complete this, if time permits, we'll see the two-way merging. There is some interesting concept called as two-way merging and then merge sort. So I wanted to tell the difficult sort is nothing but a merge sort, right? Which many people will not be able to understand. So in the next classes, we'll start with the two-way merging and the merge sort. And the way I explain every day is first 5 to 10 minutes would be a recap, or I would be asking a questions. If you are answering, that's well and good. If not, I will be repeating. First 5 to 10 minutes will be a recap of the session. Next 35 to 40 minutes would be a topic that we discuss, like writing a program, understanding a concept and converting the concept into a program. And next last 5 minutes would be what we are going to discuss in the tomorrow class. And sometimes I do give homework. once your enrollments are completed, you guys will be added to a WhatsApp group. And in the WhatsApp group, I'll be giving a homework, or if you have any questions, if you want to once you do the homework, you want to share that, you can do that. It's not a hard rule, right? Like, it's not a school, right? I generally tell students to try for 15 minutes, not more than that. And whatever we try in the class now, can you guys try this at home on your own? Writing a bubble, you take some bunch of numbers and write an algorithm for bubble sort.
Sure.
Yes.
Yeah, you can try that, right? At least you can see whether you are able to write or not, correct? And see how much time you take. Now, if you are enrolling for this course, just put your question, like every day, whatever I am discussing, just try on your own and see, that will boost up your confidence and coding skills. In that way only, you can, like, if you want to improve your coding skills, the only way is to code. Now, but now will I be sharing this code? Yes, I will be sharing, but not immediately after the class. So I'll be sharing once a week, or whenever you guys ask, or at the end I'll be sharing all the code, but I'll not be sharing the code immediately, because if you, for example, you're working on the bubble sort at your home, you're stuck with somewhere. In the next day, you ask me the question. I'm happy to answer it. But if I share the code immediately after the class, you simply look at the code and you write it. Correct? You will not ask me the question and you do not know why did I write each line of code, right? The importance I wanted to mention, that why did we write each line of code? If I don't write that, what will happen? Even sometimes I may not be able to answer your question. That's good. I'll do my homework and I'll come back. But that is the intention of my whatever the course I teach. Okay. So that's all for today. And tomorrow and after tomorrow will be holiday. And you'll be getting an email from, or some notification from Ashok IT on your WhatsApp number or email on how to do enrollment. So generally they give some information like this. Just a minute, let me share that. Yeah. So some simple information like this. So you will be having the session 1, session 2 link, and they will be mentioning the enrollment process. Like, if you are interested, where to do the enrollment, like where to do, like you can do Google Pay or account transfer, and then take a screenshot and send an email to this Gmail. You will be getting that email details from the Ashok IT. Any questions, concerns? Have you learned something new?
Yes, sir.
Yeah. So if no question, then that's all for today. So meet you guys on Monday. And if you are interested, please do enroll. Yeah.
Thank you, sir.
Yeah. Thank you all. Thanks for joining. Have a nice day.